Yeah, perfect. Okay, so hi everyone. Thanks, Susanna, for organizing this event. This is very nice. I'm super happy to introduce the first talk of this series. I hope you also stay tomorrow for the more practical events. Today we have a series of great talk. In my talk, I'll stay on a very high level view, and also I'll give you quite a history centered on around what we've been doing at HuggingFace. So I think you will also learn a lot of very interesting things and other views of the fields in the next series of talks. So I'll move to the next slide. Yeah. So you see, today we use NLP and we use text in many applications. So maybe one of the things that is the most common, I would say, in everyday life on our computer is like using Google to search some page. But as you can see now, also you can do a lot more with search engines. You can actually ask them questions and you get actually answers which are now a lot more, I would say, than just a URL of a page. This is typically a question that Google has been digested and give you an answer. Another case where you're actually also using this kind of helping tools now, for instance, is when you type in an email and you get some predictive possibility of completion that are becoming better and better, I would say. Another very common talk is when we kind of flag or like classify something. So it can be, for instance, to classify a translation that you're using on a website, or it can be also to classify emails as spam or not spam, or all these kind of things where you interact with these tools. And a more recent example that I would take about NLP technology is not even NLP anymore, is this kind of completion for copilots and code. So in all of these various areas, we're actually interacting with fairly complex and almost state-of-the-art models. And maybe the common link between all this way to interact with websites and things is actually a recent architecture called transformers. And today I'll talk a little bit about this architecture and how actually it's been the basics for us to build a very big open source ecosystem around these new tools of NLP. So all this started actually a few years ago. The date is quite recent, that's 2017, with this new proposal of a neural network architecture, which was called Transformer in this paper from Google called Attention is All You Need. So the Transformer is a neural network for processing many things, but in particular text. So on the right here, you have a very high level view of what this does. Actually, basically what we do in all these new NLP tasks and all this new way to interact with this model is that we convert some text inputs. So here, for instance, it's a question. So you can imagine this was the question that you would ask in the Google search engine, for instance. This is tokenized in a series of numbers. And then when we have these numbers, we can actually use mathematical models. So the most commonly used today is a neural network, which basically will process this with matrix multiplication, some non-linearities, and give us another series of indices of numbers. And we can convert this back actually in a text using basically some kind of dictionary, if you want. And this is on the left, you see the example of today's transformers, which is this type of neural network. You have some inputs at the bottom. You have a series of processing modules, which kind of do this mathematical multiplication, some self-attention, which kind of are here to combine the numbers corresponding to various words together. So to get some context around each word in terms of mathematical context, I would say. And then we output some probabilities of next words as indices, and we can create and generate an answer from this. So this is just a neural network. This is just a bunch of weight matrices. And if we have a big enough data set, we can train this to do any kind of task, including the tasks that I showed you earlier, like question answering, classification, translation. We started to make libraries a few years ago, just after this paper, around this transformers model, kind of sharing building blocks to build this model. And this was called the Transformers library. And actually, the success and the interest for this library was really strong. That was very surprising even for us. You can see this is the red curve. This is like the GitHub star. So this is one view of the interest in the framework. And even comparing to very widely used framework like Spark, Kafka, or MongoDB, this was really fastly growing very strongly. And there was also some typical advices or reaction from people in the field, which was this is actually the most impactful tool for current NLP. So you might be wondering a little bit like, why is this actually really impactful just to share like a library of building block? Well, the thing is that it's not only about the neural network. It's also about what is around this. And what happened in the past few years is that we had a lot of compute power that became available, mostly following Moore's law and Moore's law of the GPUs, I would say. We had also very large text data set that became available, and I talk a little bit more about that later. And then we had this thing that I will describe, which is called transfer learning. And transfer learning and the combination of these three things was actually what made the success and the interest in techniques, and as a consequence, the success and interest in our framework that we open source a few years ago. So what is transfer learning basically, and why is this important, and why are people really excited about this? Well, the typical way we train this neural network earlier, or any type of machine learning model basically, is that for each task that we wanted to do, let's say we want to do text classification for spam or not spam message, or maybe for something more recent, we want to classify like social network posts in like toxic and non-toxic, maybe to flag some of the posts that we would like to remove. What we did is that we gathered a data set on our task. We asked like user to flag posts as toxic and non-toxic. And then we randomly initialized a machine learning system, and we trained it from scratch on these data sets. And if we had another task, let's say now, instead of flagging our posts as toxic or not toxic, we would like to translate them in a diversity. Let's see if I can have this, this viewer. Oh, no, I don't have it here. Yeah, well, yeah, anyway, if we have a second text, let's say now instead of flagging this post, we want to translate them from English to, I don't know, German or like Japanese. Then we gather another task data set, we gather another set of translation, and we randomly initialize machine learning from scratch, machine learning system from scratch, and then we train it on these data sets. And that's actually not super efficient, because in each case, we'll have rather small data set that we have designed specifically for our task, and they're kind of disjoint. And yeah, okay. And the major discovery that came just after the Transformer paper was that we could also actually gather this data set together and build an intermediate knowledge representation here. So basically what happened here is that we'll gather all the data set that we have around our like social media posts, the one where we flag them, the one where we translate them, maybe some where we, I don't know, associate an image with text. And we use all this pool of text data to train a generic model. And from this generic model that here we call knowledge, we can create like smaller models that are targeted to each target task. And the very interesting thing is how here we can have kind of a generic representation of what is a social media text, for instance, a social post. And then we can start from this generic representation to fine tune it. What we call fine tune it is that it means to adapt it to each task. So then we will adapt it to the task of flagging toxic messages, adapt it to the task of translating, but we start from this pre-trained blue representation. And this blue representation is basically we call that a pre-trained neural network. So it's not randomly initialized here, it's initialized in a kind of generic way that's applicable to all our tasks. So the pre-training works like this. You start with a base model, you gather a corpus that you try to make as large as possible. So we gather everything that it still has to make a little bit of sense. So if you're working with social media posts, you will want to have this type of words, but can be very, very large. You will actually spend a little bit in compute here, but that's some expenses that will be actually useful for many tasks. So it's interesting. You spend also the time to train on this very large corpus, and you end up with a generic pre-trained language model. This one is not specifically useful for any task. It's kind of a generic model, but you can then use it in a fine-tuning stage that you can do on various tasks. Where you start from this pre-trained language model, you have a smaller data set because that's just the one that is focused on one specific task that you now want to work on. Let's say question answering now. So you have a small data set of question answering, question and answers. And you fine-tune your model. Usually it's a lot less compute intensive because data set is smaller, and you have also various easy tricks to make this faster. And you end up with a fine-tuned language model that works on your specific task. And so as you can see, this orange box here on the left is kind of the fundamental bricks that's interesting for us. It's kind of a generic model that can process and that can be used and adapt in a lot of tasks. And so the main thing we did actually at HuggingFace was to make it easy to access this generic pre-trained model. So once they have been trained, and this can be quite compute intensive, as I told you, you can actually start from them to use them in many tasks. And we've developed in parallel to our transformer library a hub where people can share, can openly access, can openly share all these pre-trained, generically pre-trained checkpoints, and also actually the one that are fine-tuned on specific tasks. So we have today more than 20,000 models. They're available in many languages. They're available in like this generic version, but also this fine-tuned version on many tasks. And you can just directly access them and try to use them on your case or fine-tune them on your specific data set. So I've been talking a lot about models, but also a lot about data set, as you notice, because that's really the core of what enabled this revolution, is having this large data set. And so last year, actually, we started another library called Datasets. We like simple names. And this one is a way to access all these data sets, and is also seen as a way to simply gather them. I talk about building large corpus, and very often these corpus are built by gathering small data sets. So if you give a simple way to access a lot of data sets, you can actually enable also a simple way to gather them as this building block of the transfer learning approach. And so Dataset is also a library that's open source and had actually also the same very strongly growing interest if you compare to some main framework used to share dataset like PyTorch, Torch Vision, tons of dataset. The HuggingFace dataset library has been growing very, very strongly. And here the idea is that it's coupled as the Transformers library, it's also coupled with the hub where you can explore and access data sets. So here we have also 4,000 data set, which is a very large number. And what is interesting is that they also span a very wide diversity of languages. I think we have more than 500 languages, I think. So obviously English is one of the most represented, but we have also a lot of, I would say, more lower resource languages that have significant amount of data sets. And the same as the transformers, it's designed to be open source, so people can openly access and share data sets, and it's very easy to access them. That's the same idea. If you're using data sets in just one line, here is an example for a data set called Wiki Atomic Edit, which is a data set gathering the edits that are done on Wikipedia. It's quite interesting, for instance, if you have a task of simplifying sentences. You have very long sentences that are too complex to process by your system, but you want to break them in smaller and simpler smaller and simpler sentences. That's actually something that people do often on Wikipedia. They take very hard to read paragraph and they can simplify the language, cut the sentences. And so this type of data set can be used to train a model to make simple sentences from complex sentences. And here, for instance, in this, well, that's just one example I'm taking, but here you see that you also have Japanese, for instance, deletion, Japanese insertion. So this is typically a multilingual data set where you can use one or diverse set of languages. And in just one line, you load the data set and you can use it directly to train a model or to gather this with another data set, for instance, if you're in the stage of building a large data set. One example, very recent example that we open source this year about using this was the T0. It's a model that we developed actually as part of a very large research collaboration called Big Science that Susanna is leading. And here we gathered a lot of data set and we try to make them comprehensible by the model by explaining in text what each of the data set is doing. So to train the model, for instance, on a sentence classification data set, we added to the beginning of the inputs, here is one sentence, here is another one, and can you tell me if this sentence have the same meaning? You can see one example on the right, and we call that templating. And by having a wide diversity of templating and combining them with a wide diversity of data sets, actually the model kind of start to understand, well, I mean, the meaning of understand is quite complex here, but start to be able to use this template, this prompt, this explanation of what we want to do to perform actual tasks and to perform a diversity of tasks. So this is a model that can do basically a very wide diversity of tasks in a single model. So that's even an improvement of the transfer learning approach. We call that zero shot. So you can try it on the web if you go on our hub and you type in T0PP, that's its name. It's a bit a research name, I know. You can try to test it. It's available. It's openly available, and you can try to test it on new task if you want. You just explain what you would like the model to do in text, and the model try to understand and to perform the task. So this is how all our bricks are connected. We have this model and Dataset Hub, which can give you models. You can then use tokenizer and transformers. So basically, you load this model in the libraries. You can also load a data set. You can train and adapt the model on specific data set if you want. And if you have a new interesting model, you can also upload it to share it again for the community, or you can upload it in a private setting to share it just within your organization. Actually, you can also. So now another thing, and I want to end on this, is also that we try to think and act on what we call ethical AI. And what is that? Well, there is some limits, and here is an example of this model. When you load a recent transformer model, and here the task on which the model is trained is to predict a masked word. So that's not a task that's very useful actually, maybe, but it's an interesting task because we can investigate a little bit the internal of the model. So we load a very commonly used model called BERT, and we give it the beginning of a sentence which go like this: this man works as a, and we ask him to predict what is the most probable job of a man. And basically what you will see at the bottom is that man has typically predicted to be lawyer, to be carpenter, doctor, waiter, mechanic. And if you just replace the word man by woman, and if you ask, okay, what is a woman typically working as job, you will have a totally different set of jobs, which are like nurse, waitress, teacher, maid, or prostitute. And here you can see what an example of, like a typical example, I would say, of what we call bias in the model. And you have to be aware that this model have this like deeply embedded in how they learn to process text. And this can be actually problematic. Huh? They say this is a chatbot or something when you're asking autocomplete and it predicts that a woman is a prostitute. That's not something you would like the model to do. And this is a deep problem with this model, and we don't really have a solution, but I think the first step is here to kind of acknowledge that here there is some bias and we should do research on how to limit this. It's not always easy to acknowledge. We had one coworker joining us recently, which was Meg Mitchell, that actually got fired from Google for somehow raising some of these issues around this model. On our side, we think it's not good to you should not just close your eyes. It's better to actually open your eyes and to make this model open and open for investigation. And so some of the work we are doing around us are called model card. We try to document and to educate around the bias of this model. And so if you know that the model is biased, that's the first step to try to stop it, right? Now, I've been talking a lot about NLP, but I want to end up just on this opening and telling you that this recent model transformers and general neural network, they are now extending a lot beside just NLP. and to, I think, very interesting direction, including speech. Speech is very, very interesting because it's also, you lose a lot of context where you just use text, right? You lose like the emotion, you lose also, sometimes we highlight some words when we're talking, and this you lose them when you're just working on text representation. And beside this, we know that our world is increasingly vision-based. We use a lot of photos, videos on the web, and it would be very interesting. Models can also understand them. More generally, biochemistry, and there is a lot of other fields where the same model transformers are showing interesting results. And so as one example, right now, we have like a collaboration or a group of researchers working on text to image. So you might have seen this example from OpenAI, which is called DALL-E, which is a model that's taken a text prompt, try to generate potential or images representing this. And this is very, very interesting here. The main problem here with this model and with the current trends is that all this is kind of developed in a private setting. We can't really access this model. We also can't, as a consequence, investigate the bias that I was talking just before. And so what we think at HuggingFace is that all this new application of model, all this extension should be developed in open source and open collaboration. So we've studied a lot of them. Here's one example, is a collaboration to fine-tune speech models. Can be used in all these kind of speech application, like if you want to emotion detection or speech to text transcription. And this, we do that as a form of community effort. So this wave to wake effort was very big. There were like 400 and actually I think more than 700 people participating in this effort. And the idea was to train speech model in many, many languages, in like more than 80 languages. And another very good example is Big Science that Susanna is leading, and which is around developing this very large language model in the open. And here we are about 700 researchers. So we think that openness and collaboration and this very open collaboration is the way that the community should go forward. Now that was all for today.